Assalamualaikum. I'm Shakira. I will present 1.0 Introduction. Statistics play a crucial role in scientific processes such as data collection, analysis, summarization, and presentation. This study aims to explore data gathering, characterize data through descriptive statistics, graphically display data, and perform statistical analysis using SPSS. Quantitative data quantifies amounts or quantifies, while qualitative data assigns names or titles to groups. The dataset for analysis comprises of 393 observations on curve wheel used per 100 km with 150 random observations selected for analysis. This study focuses on quantitative variables including liters per 100, kPl, horsepower, and weight chosen based on their suitability for algebraic operations. Next, we will move to data description. The data includes variables such as liter per 100, kPl, cylinder, horsepower, weight, and brand, with measurements ranging from numerical to string. And the sample size for the study was determined based on the last 2 digits of group members' metric numbers, resulting in 150 data points. So the study involved both categorical and numerical data with a focus on the brand of vehicles and various quantitative measures such as weight, 6 cylinders, horsepower, kilometers, kPl, and liters per 100 kilometers. Next, 2.0 sampling data and record categorical data. First, data sampling is a statistical analysis method used to select, handle, and examine a representative sample of the population, ensuring the reliability of statistical analysis results. Second, considerations between accuracy, time, and cost play a crucial role in determining the sample size with pricing required accuracy levels for statistical findings. Third, various approaches to data sampling exist, falling into 2 categories: non-probability sampling and probability sampling. Fourth, in the specific study on vehicle fuel consumption per 100 km, 152 data points were selected from a pool of 393 based on the last 2 digits of group members' metric numbers. This was then narrowed down to 150 data points to meet the research requirements. Fifth, the study involved 2 types of data, categorical and numerical. Numerical data included weight, 6 cylinders, horsepower, kPl, and liter per 100, while categorical focused on the brand of vehicles. And lastly, to enhance data interpretation, the alphabetical order of brands was transformed into numerical values for analysis purpose.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nabilah Binti Asri. My metric number is A22A1157. I will present for the part 3.0, numerical description measure. For the measures of central tendency have a mean, median, and mode. For the mean get 6.4, median 6.4, and the mode 6.48. For the measure of positionary, first quarter get 5.52, third quarter 7.13, and the interquarter range get 1.61. And the last is measure of variation. For the range get 7.85, simple variance get 1.69, and standard deviation get 1.3. Next, for the KPL, measure of central tendency, for mean get 16.43, median 15.92, and the mode 3.505. Measure of positionary, first quarter get 13.6, third quarter 1x.555, and the interquarter range get 4.95. The measure of variation range get 21.7, simple variance 14.44, and standard deviation get 3.8. Next, for the horsepower, measure of central tendency get mean get 1.38, median 1.37, and the mode 1.4. Measure of positionary, first quarter get 1.07, third quarter 1.57, and the interquarter range get 0.5, and the measure of variation range get 1.63, simple variance 0.13, and the standard deviation 0.36. The lastly is the weight. Measure of central tendency have a mean, median, mode. For the mean get 3.91, median 3.84, and the mode 3.46. Measure of positionary, first quarter 3.48, third quarter 4.28, interquartile range 0.79. Measure of variation range get 1.98, simple variance 0.25, and the standard deviation 0.5.
For the first class interval, it is 3.26 until 4.24, and midpoint 3.75, frequency it is 7. For the second class interval, it is 4.24 until 5.35, midpoint 4.735, and frequency it is 19. Class interval number 3 is 5.24 until 6.22, midpoint 5.73, and frequency 14. Class interval number 4, it is 6.23 until 7.21, midpoint it is 6.72, and frequency is 51. Number 5 is 7.22 until 8.20, midpoint 7.71, and frequency it is 20. Number 6, 8.21 until 9.19, midpoint 8.7, and frequency is number 10. Class interval number 8, class interval number 7, it is 9.20 until 10.18, midpoint 9.69, and frequency number 2. For the 4.2, it is frequency polygon for the variable of travel distance, or KPL. We can see table 2 have three key points we can refer. It is firstly class interval, midpoint, and frequency, like a table 1. For the class interval number 1, it is 9.0 until 11.71, midpoint 10.355, frequency 7. Class interval number 2 is 11.72 until 14.43, midpoint 13.075, and frequency number is 44. Number 3 is 14.55 until 17.15, midpoint 15.795, frequency same 44. 4.3 is histogram for the horsepower. For the table 3, refer to the table 3. For the first class interval, it is 0.67 until 0.87, midpoint 0.77, and frequency number is 9. Number 2 is 0.88 until 1.08, midpoint 0.98, and frequency number is 13. Class interval number 8, it is 2.14 until 2.34, midpoint 2.24, and frequency number is 7. Last but not least, 4.4 frequency polygon for the weight. Refer to table 4. We have class interval, midpoint, and frequency. For the first class interval is 3.158 until 3.405, midpoint 3.2815, and frequency number is 28. Number 2 is 3.406 until 3.653, midpoint 3.5295, and frequency is 30. Class interval number 3, it is 3.654 until 3.901, midpoint number 3 is 3.7775, and frequency it is 23. Class interval number 6, it is 4.398 until 4.645, midpoint number is 4.5215, and frequency number is 30. Class interval number 7 is 4.646 until 4.893, midpoints 4.7695, and frequency number is 7.
Hi and good day everyone. I'm Farisya and my metric number AFT2103. I will continue the presentation for the next part, which is 5.0, Statistical Analysis using Software. 5.1, Numerical Descriptive Measurements. Graphical Presentation. Table show the data of mean, mode, median, and standard deviation and variance for liter per 100, which is obtained from SPSS and also calculated manually. Result data for both methods are not too different. Next, table shows the data of mean, mode, median, standard deviation, and variance for KPL, which is obtained from SPSS and calculated manually. Result data for both methods are not too different, but the result for the Mohd is quite significant because SPSS cannot read the data accurately. In addition, table shows the data of mean, Mohd, median, standard deviation, and variance for horsepower, which is obtained from SPSS and calculated manually. Result data for both methods are not too different. Last is table for weight. It shows data of mean, Mohd, median, standard deviation, and variance obtained from SPSS and calculated manually. Result data for both methods are not too different. Next part for my presentation is hypothesis testing. First step, use this formula. Step 2, significant level is A equal to 0.05. Step 3, doing calculation and get the result T equal to negative 31.69. Step 5, we can conclude that the two sample means are not equal or there is significant difference between the two sample means. Let's go to the next part, which is ANOVA. They also have 5 steps. Step 1, use this formula. Step 2, the significant level is 0.05. Step 3, get the calculation from SPSS. Step 4, reject HO if F more than FA, VA, V2. Critical region. F more than F, 0.05, 3.146 equal to 2.818. Last step, conclusion. Fail to reject HO since F less than F, 0.05, 3.146, 0 less than 1.818. Therefore, there are no significant difference among the treatments. For the last part that I will present is 5.3, which is correlation analysis. According to Pearson correlation analysis by using the SPSS, the relationship and strength between the variable by measuring them. Next, the correlation between liter per 100, kPl, horsepower, and weight. The R values between liter per 100 and kPl is negative 0.946. Liter per 100 and horsepower is 0.717, and the R value for weight and liter per 100 is 0.717. Perhaps there is no problem for multi-coronarity. That's all from me. I will pass the presentation to the next presenter. Thank you.
Hello everyone, my name is Amira Madihah with Zulkarnine with metric number A22B1067, and I will present about 4.4 first, which is confidence interval. Confidence interval is a range of value within which is the population parameter is expected to occur. Based on the result of SPSS, the standard error of the variable, which is liter per 100 km, is 0.10960. We can conclude that the population parameter is between 6.1662 and 6.5994. Next is for 5.5, which is prediction modeling. First, as the table shown in this slide, the normality test used to determine if the sample data was scattered from a normally distributed. The Kolmogorov-Smirnov and Shapiro-Wilk normality tests are presented by IBM, which is SPSS version 27 software. The Kolmogorov-Smirnov and Shapiro-Wilk of normality on the cells give a p-value of 0.026 and 0.024, which is lower than 0.05. According to the table of models summary and ANOVA, the R-square value is 0.603, which means 60% of variation in liter per 100 km can be explained by weight, horsepower, and kPl. The adjusted R-square is 69%. This can be concluded that the relationship between the model and the dependent variable were connected to each other. Lastly, we move on to the coefficients. The equation is shown as the slide, which is B0 plus B1x1 plus B2x2. All the predictor variable, liter per 100, kPl, horsepower, and weight appear to significantly influence the number of cylinders in the model based on their p-value, which is p less than 0.05. As all are below the common threshold are statistical significance. Therefore, it can be concluded that the equation suggests a relationship between the number of cylinders in a vehicle and the variable liter per 100, kPl, horsepower, and weight with their respective coefficients, showing the individual impact on the predicted number of cylinders. I guess that's all from me. Thank you. And I will pass the presentation to Shakira.
Lastly, for our conclusions, The statistical analysis of vehicle fuel consumption data provided valuable insights into the factors influencing fuel efficiency and the relationships between different variables. Secondly, the analysis offered a comprehensive understanding of the distribution of vehicle fuel consumption data per 100 km through graphical presentations including frequency distributions and histograms. And lastly, hypothesis testing using t-test and ANOVA was conducted to assess the significance of difference in means and the relationships between variables. That's all for us. Thank you.